Hello guys, in this video I am going to give an introduction about the PARCS. PARCS is a Purdue Advanced Reactor Core Simulator. It is originally developed by Purdue University, USA. PARCS is a nodal core simulator. It used to analyze PWR, or we can analyze BWR. PWR means pressurized water reactor and BWR means boiling water reactor. There is only one main difference between the BWR and PWR. Uh, Before we understand what is the boiling water reactor and what is the pressurized water reactor, what is the difference, first we just see the flow of how it works. There is a reactor vessel, that's where the reaction happens and heat releases. Then water get heat up, then it moves to the it convert to steam, then it moves to the turbine. Then turbine rotates, which is connected to generator, then it produces the electricity. Then that water comes to condenser and it's cooled down here, and that water again goes to the reactor vessel. This is how generally the nuclear fission reactor works. And in boiling water reactor, the main thing we have to notice is that in the reactor vessel the water is directly converting into the steam in the reactor vessel. Then the steam directly go to the turbine. But in the pressurized water reactor, here water is get heat up in the reactor vessel, but it is not converting here as a steam, because pressurizer is make sure that it will be in liquid state. Then it will then water goes to the steam generator. In the steam generator, water get into converted into steam, and that steam go to the turbine. So the main difference is that where the water is converting into the steam, that is one of the main difference between the BWR and the PWR. Then we will understand there is a fuel pins and control rods. As we seen in the reactor vessel, there are rods aligned in the reactor vessel. There are control rods and fuel fins. Fuel fins where the rods where fuel is filled, and control rods are the rods which help to control the reaction. If the control rods goes down, then the reactor will slow down and power will go down. If you take out the control rods, then the reaction increases and the power will go up. So basically PARCS is the nodal core simulator. Means in the reactor there will be thousands of fuel rods and the control rods, where what PARCS does is like it simulates that fuel rods and shows us the different parameters. But in our laptop, in the laptops or normal hardware, we can't simulate them because there will be thousands of fuel fins are there. It takes a lot of processing power and the time. But what does PARCS does is like it will group them many pins into one bigger 3D block that called nodes. And also it uses a nodal expansion method which help to like reduce the time and it accuracy. It will give us an accuracy simulation of the different parameters. And it solves a steady state and transient state Newton equation. Means it uses it solves the equation and gives us a simulation. There's a two states here, steady state and transient state. Means steady state means it will give us a snapshot of the reactor. Means there's the parameters will be fixed and it will give us a snapshot. But transition state is like things will be changing, parameters will be changing, and it will use different changing simulation up to the parameters. It predict three different things like Kf, effective multiplication factor, and neutron flux is a neutron intensity, and power distribution and heat speed. These are the three main things it will predict, and there is other features also, but for now we'll stick for the three main features. And Kf is the effective multiplication factor, where it is like it tells us like how many neutrons in the next generation compared to this one. I mean, it is comparing it is comparing to the one reaction and gives us the number. Like if it is equal to 1, that means it is a critical steady power, there is no change. If it is less than 1, means its power is going down, means subcritical it called. And if it is more than 1, it is supercritical, means power is rising, reaction is rising. It also predicts, PARCS also predict neutron flux, where neutron flux is a neutron intensity, means how many neutrons are flying through a unit area on each second. That's what neutron intensity. And it also predicts the power distribution, how it is spread throughout that reactor, and it shows us in 3D simulation. These are the three parameters it mainly predict then. And main features of the PARCS is like it uses the nodal method, it makes it faster and accurate, and because it can be used in both PWR and BWR. Also it uses something called two-way coupling, air power and temperature densities, where we can produce a realistic transients and safety analysis. Okay, that's all for today. In the next video I will talk about how to install the PARCS, and is it open source, how to start with the PARCS. Until that, bye.